Yeah. So actually you are thinking that you have assigned the values, but in fact you haven't yet assigned any values to the capacitor. See, when you just double click on any kind of component, it will display this particular pop-up menu, symbol properties. Here you can find the value option, right? Under the fields, you can find the value option.
Okay.
So for that value, there is a text C which is written over there. So here you need to modify the value. Let's say, if it's a C, it doesn't necessarily convey what is the capacitance of the capacitor that you added.
Hmm.
So here you need to change the value.
Okay, sir.
Yeah.
What should I change it to?
So you can put something like 1 microfarad, 1 UF,
Okay.
1 UF.
Okay.
Yeah, that's fine. So that means it's a 1 microfarad. So actually,
Yes.
instead of micro symbol, we usually use letter U, which is very similar to the micro symbol.
Okay, sir. I understand now.
Yeah,
Okay.
and that is 1 microfarad. See, actually, for VCC, it's better to use two different capacitors. Okay,
Yes.
which we call it as the bulk decoupling. So usually we use two capacitors, and moreover, you are having two different grounds, right? So why again assign a netlist, a separate ground netlist to both the capacitor? You can directly short those two terminals. Is that clear? So rather than having two different grounds, I'm talking about the upper surface, like where you are having VDD and VDDIO.
Okay, okay. Let me collect it before you go, sir.
Yeah, just delete those net labels and directly short them both. Yeah, directly short them. Okay. Yeah, now here you can put a ground, directly the ground symbol, power symbol, ground. Yeah. Yeah. See, if you are having multiple grounds, no need to assign a netlist again, because if they are very far away, then you can assign. If they are very close to each other, you can directly put a ground. See, and moreover, if I just check the schematic, it is not completely in a organized way. See, both
Okay, sir.
capacitors are interlapping each other. So you need to give at least a
Le-
little bit of spacing between both the capacitors.
Okay,
See,
let me first do the grant, sir,
yeah,
so that I can collect it.
yeah, perfect. Okay. So just to move the above capacitors, give some good spacing between the capacitors, or else it would be very clumsy.
Okay.
Just click on the capacitor and try to move it. Okay.
I'm coming, sir.
Yeah.
1 minute.
Yeah, yeah, sure. Take your own time.
Okay. Can I join?
Yeah, yeah, you can join. See, do you know how to move multiple things at a time?
No, sir.
Okay, just use your
I can
mouse.
highlight them. I can highlight them and move them at a time.
Okay, fine. Actually, you can even move multiple things at a time. Okay, I will show you that in the KiCad class, which starts at 6 p.m. I will show that.
Oh, this is fine, sir.
Yeah, now it's good. And I'm talking about the above capacitors, like which are connected to, which are in between VCC and see, and also one more thing. Sorry, give me a second. Okay, you are giving V plus over there, right? Okay, that's fine. Uh, Between C1 and C2, you can add some space. because
Okay.
both capacitors are overlapping on each other. The symbols are overlapping. You can add some space between them.
Like this.
Yeah, okay. Yeah, that's fine. So for one capacitor, you have given 1 microfarad, right? Yeah. Also,
Okay.
for those resistors, give 10K. Okay. Resistors also give values 10K for all the resistors. There are three resistors, right? R1 and R2, R3. For them, you give 100K. Sorry, 10K.
10K.
10K. Yeah. That means 10 kilo ohm resistor. Don't modify the reference. Just modify the value. 10K. Yeah. Okay. Click on OK. Yeah. Do the same. Yeah. For R4 as well. R4 also 10K. Yeah. So, and if you check the value which is assigned to R2, see it is above or behind. It is overlapping with the symbol. So that's why you can move the value label a little bit towards the right. No, no, not the designator. Designator is fine. Just I'm talking about value. You can use Control Z. Yeah, yeah. Okay. So yeah. So now coming to the capacitor. So for one capacitor, you are given 1 microfarad. Let's say C1. For C2, you can give 0.1 microfarad. It's not 100, 0.1. 0.1 UF, not F, UF, micro.
Okay, so US.
Yeah, that's fine.
So this one, sir, I can delete it and use.
So, do you have any idea? 1 microfarad means how much? Any idea?
Yes, yes. I'm studying electronics. I'm a minor in electronics, but I'm studying it now.
Yeah. So, 1 microfarad means 10 to the power of minus 6 farad. 10 power minus 6.
Hope hope I get this thing right, sir. Yes.
Okay, you are using a VS, right?
Or should I change it?
Yeah. You can give the name VCC rather.
This one I should change it to
Yeah, you
V60.
need to change that as well. No, not here. You just no need to put the symbol. Here you can directly put the net label.
This one, sir.
Yeah, there you can directly put the net label. Symbol not required. Just double click on V plus. Double click on the V
Vi-
plus. Yeah. So on the left side you can see the properties, right? Label properties. There you can modify the text. Instead of V plus, you just change it to VCC. Yeah. Okay.
I'm still getting little error, sir.
Yeah, I'm checking. Input power pin not driven by any output power pins. Okay. It is showing there are total pin 1. Okay, you are using a 2 power pins, so I need to check. Yeah. So it is also highlighting that particular area, right?
Yes.
Yeah, let me check.
Hello?
Yeah. So once can you just go to the properties of that particular power symbol?
Yeah, give me 1 minute, sir. 1 minute.
Yeah, sure.
I'm coming, sir.
Yeah, sure. Fine, definitely.
1 minute. Hello. Can you hear me?
Yeah, I can hear you.
Okay. It's perfect. Sorry, my system, I need to. We are in Nigeria. We don't have electricity. They have taken the light. I'm sharing the screen back.
Yeah, sure. No worries.
Hello?
Yeah, hi.
Hello, guys.
Yeah, I actually Abdul Hafiz is sharing his screen, and
Yes, sorry, I have to use another system,
oh,
and
okay,
then
it's
sorry.
you, right?
That
Okay,
system, yes,
okay.
that system people, but I don't have Thai card on this system, but I can share one or two things with you. Yeah, I've done. 1 minute.
Yeah, sure. We can also take additional hours on Saturdays as well.
I'm back. System is on back. 1 minute. System is
Sure,
back. Just give me 1 minute.
sure.
Hello?
Yeah,
Hello. I'm back, sir.
yeah, you can share your screen.
So- Okay. Let me share my screen.
So actually in KiCad, we need to use something called as power flag. Okay. So if
Okay.
you actually what you have ran couple of minutes ago, which is actually called as ERC. So ERC and DRC little bit they are different. So DRC refers to design rule check, where ERC refers to electrical rule check. So ERC only
Okay.
primarily focuses on electrical connectivity related verification. So what you have performed
Mm.
is the ERC. So it returned an ERC error. It's actually not a DRC error. It's an ERC error. So to avoid that ERC error, you need to add something called as power flag. So can just go to the
Mm.
place option, place. Just like how you, yeah, click on place symbol. So you can search for something like a power flag. Then you will get one symbol. You need to add that symbol wherever it is showing that particular error while you are performing the ERC. So at those
So
locations you
it's
can add a
loading.
power flag. Then it will resolve.
1 minute. It's loading, sir.
Yeah, sure.
So now in KiCad, the way they structure it is far better than using Easy DA.
Yeah. So which software you felt a little bit easy? ECED or KiCad?
KiCad, professionally, KiCad, people are using it more than Easy DA,
Yeah.
but it's because of the KiCad.
Right.
Then the web version of the KiCad, Easy DA, make it easy for you to work on any system where you are, and you
Yeah.
can work as a team in a KiCad, which
Correct.
in a
Correct.
ETDA, but you can't do that in a KiCad. So I'm here,
Yeah. So in the place symbol, you can search for something like a power flag.
power flag.
Right.
Why is it not responding?
Yeah. Sometimes it behaves like that only.
I've used it many times. So I search for power flag, so I can do that later. Power flag, sir.
Yeah. Sure. Okay. Fine. So you can
So
just add
now
a power flag wherever it is showing that particular error. You can try adding a power flag. So if it
I can
same
add
well
what, sir?
power flag,
Okay, after power flag, what should I do?
that's fine. As of now, your schematics are perfect. Good to go.
Okay. Should I use to replace the ground and the power?
Didn't get you. Can you just rephrase the question?
Okay, wait, it's loading. Why is it angry?
Uh,
Okay, 1 minute. Let me.
I think is your system having enough space, or is it
It's
completely full?
32. It's a 30 gig, 32 gig RAM.
Yeah, because as you can see, even the task manager is also not loading the applications. And also one more thing, Abdul. So for your schematics, you can even, yeah, I think he left. Yasya prasado prasado.
Hello?
Yeah. So
Yeah, thanks.
I'm sending you two pictures in a special class group. You can just refer to them. So you can also add something like a power indicator. You can add a diode like LED. So for power indicator.
Okay.
Yeah,
So
and
now,
remember for LED you can use 1K resistor rather than 10K. You can go with 1K resistor. If you use 10K, the
yeah.
brightness will be too much reduced, the intensity of light. So you can go with 1K resistor.
Okay, sir.
I will be posting
So
the
what
images. Yeah.
the the KiCad loading for the food library. So I think that is what once the library is loaded, we do that. So the last question is: I will draw more mode. I will draw more sensors. Are you with me? So I
Okay.
will draw
Yeah.
more sensors, and I'm trying to prepare my diagram for my. Let me just show you. So once I finish, you try to correct me. I'm trying on ASP32, and I'm
Sure.
carrying my guys along. Any question I ask you, we try to do a class after the class you give us, so that we practice more and more.
Sure. Sure.
But
Definitely.
let me show you. I'm already doing this one. Yes, my ASP32. I'm building a very robust ASP32 so that you can correct me on what and what to do. So because is Ayub on the line?
Sorry.
Ye- Yes, I'm on the line. Though we are about to pray anyway, but I'm
Now,
on the line.
are you studies electronics in school? So it's no more than electronics than me, but majorly I minor in electronics, but I write embedded system. So I can simulate anything I'm doing. Like these are all my
So
sensors.
sorry, sir. Please spare me. Sorry, sir. Spare me 10 minutes to come back to the class.
And so don't worry, anything we discuss, I will tell you. So I'm showing my tutor. These are my sensors, sir. So I have my sensors already.
Oh,
I've
okay.
been doing embedded system for the past 10 years, but I'm not into to PCB. So this is my first time of trying PCB as a guy. So which I
Yeah.
really
So you
enjoy so
have been
much.
working on sensors since 10 years, but this is the first time that you are trying to shift to PCB, right?
Yes, I find it very interesting. If I see people like you to give me courage, I find it very interesting. I want to do a lot of things on my own. I learn how ASP32 works. You understand?
Yeah, yeah. So now you
And
want to
I'm able to read.
try to make something like a sensor like with ESP32, right? A PCB.
Yes, I've already started.
You have always
Let me
started.
show
Oh,
you.
nice.
Let me show you. It's loading.
Yeah, sure.
I've already started the SP32. Let me show you. But once I finish, you can assist to correct me.
Yeah, sure.
Let me share it with you. So I make sure I read a lot of things on it before starting the project.
Yeah,
So this is where I stop.
okay. So can you just zoom a little bit so that I can go through it?
This is my micro controller SP32.
Okay,
I, so this is microcontroller section. This is a power LED logic.
okay,
This is a power supply. This is a LED
okay.
indicator, and I have IP because in Nigeria electricity has been a problem. So this is
Yeah,
IP 5332, and I put Type C both. So I will complete it by next tomorrow, so I can share it with you. You can correct me and
yeah, sure. You can do one thing like once you're done with this particular thing, you can just export the schematic into PDF and you can just post in the same group. So I will go through the entire schematic and I will come back with you. What are all the changes needed and how can you improvise it to achieve more efficiency?
I can share the project with you.
Yeah,
You
sure.
understand, sir? So
Yeah.
if I share the project with you, you can easily correct the project. So I think
Oh,
it's going to
okay,
load
fine.
now.
Yeah,
It's going to load now. Place symbol. Now it's loading.
yeah. Power flag.
Power flag.
Give some space and type flag. Yeah, the first one you can see that, right? Yeah.
Where should I use it, sir?
You just put it a little bit aside, not in the main schematic. You can put it aside. Okay, just like
Okay,
you have
I've done
placed the connector, 1 into 6 connector, just like you can put it aside. And for VCC, okay, for instead of VCC, can just go to place option again.
it. Okay, sir.
Yeah. So just type a power again.
I've done it, sir.
No, no. Okay. Just type only power.
One power. Okay. Hello, sir.
Yeah, yeah. So do you have any idea like at what voltage like BMP 280 usually works? It is operated under I mean which voltage? Any idea?
I don't understand.
So what is the operational voltage of BMP 280 IC?
It's 3.2.
Yeah, 3.3 volt. So in that
Yes.
place option, if you go to the power, then you can find 3.3 volt power flag. Okay, so you
Okay.
can
Okay.
keep the power flag at the same time for VCC. You can place a 3.3 volt instead of VCC. You
Okay.
can go with a 3.3 volt.
Okay.
Just type remove the flag. It will show you some couple of voltages. Among that, you can select 3.3. Yeah, yeah. Now instead of VCC, remove that VCC. Instead of that, you just put this 3.3 volt. Yeah. So copy the same symbol again. Control C and again Control V. Yeah. So just change the orientation towards the downside, like 3.3 facing towards down. Again, one more time. You need to connect this 3.3 volt to power flag.
Okay. Okay. Okay.
So then KiCad will able to understand that this 3.3 volt belongs to a power flag, power supply rail. It's better if you can rotate it again 90 degrees one more time.
Okay, sir. I'm coming.
First click on that 3.3, then try to use the rotate option. Yeah, yeah, yeah. Perfect. So similarly for ground also again you need to put a power flag. It's not only for the VCC 3.3 volt. You need to put the power flag for ground even.
For grand.
Yeah, I mean take another power flag symbol in the same way as you did for 3.3. So instead of a 3.3 power flag over there, there you can put ground. Yeah. So now again can you just run the save and again just try running the ERC. I think that VCC needs to be changed. You can give 3.3 volt directly to just change that to plus 3.3 V. You can change the text. That's fine. Okay. Yeah. This is also accepted. Yeah. Okay. So again can just run the ERC.
Perfect.
Yeah. See that means so this is the biggest difference in ECEDA and KiCad. So in ECEDA you just no need to use any kind of power flags.
Okay,
But
sir.
here in KiCad, if you are using any kind of no matter it's a VCC or it's a ground. So no matter about polarity, if you are using the power supply rails, it must be connected, it must be tied to the power flag. Then only KiCad will able to recognize that it belongs to power, I mean power rail.
Okay, sir.
Yeah. So
I
now as
I
you can
get
see
it.
now no ERC errors. So this is one important point. You have asked, you have really, it's a good question that you have asked.
Okay, sir.
Yeah.
This is the only problem I have now.
Okay.
The
You can,
routing.
you,
I've not
yeah,
gotten it.
you can move them.
You said?
You can move those resistors and you can arrange it in a, you know, much organized way. You can move that. Yeah. See, you can just take the reference of the original board and just compare with that. Okay, how these resistors are actually organized, well organized in the original board.
Okay, sir.
So
But the question I want to ask.
I'm not telling you to just put in the exact same fashion. So at least a
Okay.
similarity. So no need to put, because we might be adding additional resistors, right?
Okay, sir. The
Yeah.
question I want to ask is, when I'm doing my routing, are you with me,
Okay.
sir?
Yeah.
All these cable that overlap each other, how should I treat them?
Can you just repeat the question?
In my routing, if I'm doing my routing, you
Okay.
see all these cable that overlap each other, how should I treat them?
Yeah, so that is the biggest thing. So you must strategically route in such a way that it should not overlap. So that is the biggest challenge. So this
Hmm.
cannot be explained through a PPT or through a session. So you need to try different multiple ways. So you can pick the best way. Okay, so you need to strategically, you need to think. For that you need to have some creative ideology, creative thought. So you need to strategically do that. So that's why you can take the help of two layers if you want. So some of the layers you can route in the upper top layer, front copper, and some you can route in with the help of the bottom copper.
Okay, okay. So the question I want to ask by tomorrow, sir, I just need something from you. I use Dex, any desk.
Okay.
So maybe tomorrow I can share my any desk. You can take my system and use this one as an example. Once you just do one for me, I'm okay.
Yeah, sure, definitely.
So by tomorrow, maybe if you have any desk, I share my any desk login with you. You take over my system, you control it, and you arrange. Once you arrange one for me, I'm okay.
Okay, okay, fine.
Thank you so much.
Yeah, thank you. Bye, take care.
Thank you. Yes, sir.
Yeah. So again, we are having a KiCad class in couple of minutes.
I will join, sir.
If you are free,
I
you
will
can
join.
join.
I will join. I'm much available. I will join.
Yeah. Okay.
Thank you, sir.
Thank you.